If you are joining us on the video, we are picking up on Objective 11, and this is part 2. We are now going to find trig functions for terminal points on the unit circle. Okay, so the first thing you need to know, and we talked about this the other day, and some of these are you've heard of. Like the other day I told you that sine is equal to the y. Okay, so we already know that. We know cosine, and I'm using cosine of t. It can be cosine of x. I don't like to use cosine of x because cosine's really the x coordinate. Does that make sense? So I'm just using t as a variable. So please don't get confused by the t. But t is like the point. Cosine of pi over 3. Does that make sense? T is just a variable that represents a number. Okay, in this case, it's going to represent a degree or a radian. Okay, but cosine is going to be equal to your x. Tangent is going to be equal to the y over the x. And I'm going to refer you back to geometry in just a minute, and we're going to talk about how we know. We talked a little bit yesterday about SOHCAHTOA, and I'm going to refresh your memory and how we know that sine is equal to the y, and cosine is equal to the x, and tangent's equal to the y over the x, because it has to relate back to those functions and rules that you learned in geometry. Okay, so new functions for you, because you told me yesterday you've never heard of these. Cosecant is the reciprocal of sine. It's equal to 1 over the y. Okay, and this is just a restriction. Don't get confused by the y can't equal 0. All that's saying, how do you know y can't equal 0? Because it's dividing, you can't divide by 0. So it doesn't really affect your problem at all. We know that you cannot have a 0 in the denominator. So I'm just telling you right now that the cosecant, as long as y is not equal to 0, is equal to 1 over y. Okay? Your secant is the reciprocal of x, so 1 over x, and your cotangent is equal to x over y. Okay? I will tell you this. Most students confuse. They think cosine, cosecant, and they think that cosine and cosecant are reciprocals, because I guess because of the co, they sound alike. So tell yourself now that they're not. Okay? I always remember that, like in my head, I think cosine and cosecant should be reciprocals because they sound alike, but they're not. Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. Any questions on that? So let me just really quickly refresh your memory and tell you how this works, okay? So if we know, if we're working in the unit circle, first of all, this is a leg, but we would say, like if I'm talking about this angle right here, okay, we would say this is the adjacent. What's adjacent mean? Adjacent means beside. So this is the side that is beside the angle. Does that make sense? Which one, what side would this be? This would be the opposite. This is the side that is opposite from the angle. And we called this one the hypotenuse. Hypotenuse. Okay, so some old hippie caught a high tripping on acid. Correct? That's what y'all told me yesterday? I shouldn't record that, should I? Okay. So that's what you told me yesterday. So we knew that our sine was equal to the opposite over the hypotenuse. That's what you learned and that was like a fraction. Any questions on that? We knew that the cosine was the adjacent over the hypotenuse. And we know that the tangent is the opposite over the adjacent. Okay, so you tell me this. First of all, if we're going to refer this, that's what you learned in geometry. Let's put it in terms of unit circle. If we're going to refer this to the unit circle, how much is the hypotenuse? It's equal to 1. Okay, because we are talking about the unit, 1 unit circle. Okay, it just depends. Maybe we should take the 30-degree angle. Okay, so on your did I do with my unit circle? On your unit circle, I want you to go to 30 degrees. You tell me what was the x and what was the y. Square root of 3 over 2 is your x, right? Everybody agree? And your y, so I'm going to go over square root of 3 over 2, and I'm going to go up 1/2. Any questions about that? So far, so good? So let's look at the sign. If we looked at the sign, it would be the opposite. So what's our opposite? 1/2 over the hypotenuse, which is 1. What's anything divided by 1? So what are you telling me now? That our sine is equal to what? Which is which coordinate? The y. So this is our sine. Does that make sense? Our sine is equal to the y. That's how that comes about. Okay? Where did I get these numbers? Because I got them from my unit circle. I'm at the 30-degree angle. Does that make sense? And we know, like, when you plot a point, you go x and then y, right? So the x coordinate here is square root of 3 over 2, and then the y coordinate is 1/2. And we got square root of 3 over 2 and 1/2 for when we, like, determined, like, when we broke down our unit circle and we used our 30, 60, 90 triangles to find the x and the y's. Does that make sense? That's how we got those numbers. But I'm just using my unit circle right now. Okay, good question. Okay, so cosine, you learned in geometry that it was the adjacent over the hypotenuse. Well, let's look at it here in terms of, and I just picked the 30-degree angle. I could have picked any angle on here, but I'm just showing you how it works. Okay, so the adjacent would be what? Square root of 3 over 2, and the hypotenuse is 1. So anything divided by 1 is just square root of 3 over 2. And we know, is this the x coordinate or is this the y coordinate? This is the x coordinate. So you're telling me right now that your cosine is equal to your x. Okay, which is what I just told you. Okay, but I'm just kind of telling you this is why it is that. Okay, and then I just told you that we know that tangent is opposite over adjacent. So you tell me, what's the opposite? 1/2. What's the adjacent? Square root of 3 over 2. How would I simplify that? You do, yeah, you do your trick. Here. So here's where it's going to really come into play here. So 1 is going to be on top. What's 1 times 2? 2. And here, what's 2 times square root of 3? And what happens? Those cancel, but what do you get? 1 over the square root of 3. So then this is going to become, you can times it, you got to rationalize it, so then it becomes square root of 3 over 3. So that's going to end up being your tangent. Okay? And your tangent's not on your unit circle. Does that make sense? So I need you to understand, does everybody, thumbs up if you understand that your sine is equal to the y coordinate. So when I ask you, like, for example, everybody look at their unit circle. What is the sine of 2 pi over 3? What's the sine? The sine's equal to which coordinate? Square root of 3 over 2. It's the y. I need you to understand this is x comma y. The sine, when I say what's the sine of 2 pi over 3, it's the y coordinate, which is square root of 3 over 2. Okay? Thumbs up if you understand that. Okay? If I say what's the cosine of pi, it's -1 because it's the x. Okay, I need you to understand that. From here on out, when I say what's the cosine of this, I'm saying what's the x coordinate. Okay? Now, your tangent, you're going to actually have to work out. Do you understand that? Your tangent, you're going to have to work out. You're going to have to divide the y by the x. Okay? Based on what I just showed you, I gave it to you based on SOHCAHTOA, because that's what you were familiar with. But this is the rule, okay? It is the y, it's the opposite divided by the adjacent. It's the same thing, okay? But it's the y divided by the x. And if you have to, you will have to simplify it. And if you have to, you will have to rationalize it. Okay, so we're going back to those pre-skills that you got. Okay, so my question is how are we going to figure out cosecant, secant, and cotangent? Yeah, if I were you, I would start with these, and then get your answer, and then just take it and flip it for now. Okay, and then we'll get going how to do it. So, let's look at some examples. Oops. Do is we're going to find all 6 trig functions for pi over 3. All 6 trig functions for pi over 3. You want me to give you a second and let you kind of fiddle with it? So I want you to find, this is what I want you to find, and then I'm going to give you a couple seconds. I want you to find the sine, the cosine, the tangent, the cosecant, the secant, and the cotangent. Okay, for pi over 3. So I'm going to give you, take 5 minutes. All right, here we go. So let's look at this. This is pi over 3. So you tell me, what's the sine of pi over 3? Sine is equal to the y. Isn't sine equal to the y coordinate? First of all, let's talk about what coordinate we're using. We're using 1/2 and square root of 3 over 2. Okay, because I heard some people say 1/2, some people say square root of 3 over 2. Okay, so tell me, which one's the x, which one's the y? Okay, so your sine should be square root of 3 over 2. Okay, what's the cosine? 1/2. What's the tangent? Square root of 3. And we know that, and please listen to me carefully with this, it's the sine over the cosine. You should be starting very comfortably to realize that when this and this are the same, what's going to happen? It's just going to be, they're going to cancel, and it's just going to be square root of 3 over 1, which is just square root of 3. And so, like, when I list it out, like, this is how I do it as I get to my other ones. When I list it like this, I imagine my fraction bar right here, and I can kind of do these in my head because I go, okay, I know those cancel, and so I know it's square root of 3 over 1, or square root of 3. Does that make sense? Like, as you list it, you can start to do it. Okay, just be careful. Now, if you're not there yet and you don't realize that that cancels, then you still need to be doing this with this, okay, and actually dividing them until you start to get quicker with it. I mean, no, if it was just 3 over 2, it'd still be just 3. So let's keep rolling until we get to one. Okay, cosecant is the reciprocal of the sine. So when I take the reciprocal of square root of 3 over 2, what do I get? So you get 2 over square root of 3, but then what do you have to do with it? You have to rationalize it. Y'all sound so excited. So this becomes 2 square root of 3 over 3. Any questions on that? Because I rationalized it. Okay, all right. So the secant is the reciprocal of cosine. So it'd be equal to 2. And then the cotangent is the reciprocal. Now there's a couple different ways you could do this. You could just say the cotangent is the same thing as what? The reciprocal of tangent, which would be what? 1 over square root of 3, which would be square root of 3 over 3. Once you rationalize it. What else could you do? If you know that you can divide sine by cosine to get your tangent, you could divide cosecant by secant to give you cotangent. Does that make sense? because these are just reciprocals of those. So if you can divide those to give you tangent, then you could do reciprocals of, you could just divide cosecant by secant to give you cotangent. But anyway, it's going to be square root of 3 over 3. How many were able to get those? Good. Any questions for those that did? Okay, so I'm going to clear this out, and I want you to try another one. Okay, I want you to use pi over 2. I'll give you about 4 minutes. All right, so let's talk about this one. Tell me, what's the sine? 1. What's the cosine? 0. What's the tangent? So what is it? What would my fraction be? 1 over 0. When 0 is under the fraction bar, it is undefined. Okay, so the tangent at pi over 2 is undefined. Any questions? You cannot have a 0 in the denominator, so that one's not possible. Okay, all right, so what would the cosecant be? 1. What's the secant? Undefined. What's the cotangent? Oh, no, secant's 0. What's cotangent? It's still Oh, let me think for just a second. Sorry, I'm not thinking. All right, here we go. So the reciprocal of 0 is going to end up being 1 over 0. I agree with you. It is undefined. Okay, and so the reciprocal of the cotangent is going to end up being 0. Because the reciprocal, like if the tangent was 1 over 0, flip that, what would it be? 0 over 1. Does that make sense? And so you can't have a 0 in the numerator, so it would be 0. Sorry about that. Brain fart for like 2 seconds. Any questions about that? Everybody good? Yep. All right. Let's roll on. Oh, look, we had pretty little boxes to put these in. Oh, well. Not anymore. Okay, so that's it. We're just practicing doing sine, cosine, tangent,